For centuries, humanity has gazed at the stars, weaving stories, crafting equations, and dreaming of our place in the vast cosmic tapestry. But everything we thought we knew, our physics, our cosmology, our understanding of space and time, has just been shattered. The James Webb Space Telescope, humanity's most advanced eye in the sky, has uncovered something so profound, so inexplicable, that it defies every rule we've written about the universe. Galaxies too ancient to exist, planets too massive to form, structures too perfect to be random, and a signal, steady, rhythmic, and utterly unnatural, that fits no known model of the cosmos. This isn't just a discovery. This is a seismic collision between what we believed and what is. The James Webb Telescope may have just delivered the most shocking warning and the most tantalizing invitation in human history. If this is real, everything we thought we knew about the universe is wrong. In a series of breathtaking deep-field observations, the telescope captured images of the universe so detailed they stole the breath of astronomers worldwide. But hidden within those stunning visuals was something far more unsettling. In a distant galaxy cluster, researchers spotted perfectly aligned points of light, symmetrical, almost mathematical in their arrangement. These weren't the chaotic, messy patterns expected from galactic evolution. They were precise, repeating across vast distances in ways that seemed to mock the randomness of the cosmos. In another spiral galaxy, strange gravitational patterns emerged, movements that laughed in the face of our most trusted models. The deeper the telescope peered, the stranger the universe became. Patterns repeated across billions of light years. Structures gleamed with geometric precision, and what was supposed to be a chaotic void began to look like something else entirely. Scientists scrambled for explanations, calling it coincidence at first, but the anomalies piled up. Too many, too frequent, too perfect. Whispers began to spread. What if this isn't randomness? What if this is order, a kind we're not yet ready to comprehend? Among the telescope's many targets was an exoplanet hundreds of light years away, a world that left astronomers speechless. This planet, 7 times the mass of Jupiter, orbits its star at a distance 3 times that of Neptune. Its star is barely 15 million years old, a cosmic infant. By every known theory of planetary formation, this world shouldn't exist. There's no visible protoplanetary disk, no leftover debris, no gravitational mechanism to explain how such a massive planet could form so far out, so fast, and remain stable. Its surface glows at over 1,000 degrees, a fiery enigma in a system that shouldn't have had time to build it. Some researchers dared to ask the unthinkable. What if this planet isn't part of its current system at all? What if it's a relic, a survivor from a star system long gone, somehow transplanted or deliberately placed? For now, there are no answers, only a glowing giant that challenges everything we know about how worlds are born. Then came a discovery so surreal it sent chills through the scientific community. The telescope imaged an Einstein ring, a gravitational lens formed when a massive galaxy bends the light of another directly behind it. But this ring, circling a distant galaxy, wasn't just any lens. It was nearly perfect, a complete, uninterrupted circle of light with such mathematical symmetry that even seasoned astrophysicists were left stunned. For such an image to exist, the alignment between the two galaxies would need to be precise to fractions of a degree across billions of light years. That's not just rare, it's statistically impossible on a cosmic scale. Gravitational lensing is a known phenomenon, But this level of perfection raises questions that echo far beyond physics. Could this be a glimpse of a deeper symmetry woven into the fabric of space-time? A hint that the universe isn't the chaotic sprawl we've assumed, but a system governed by a geometry we've only begun to glimpse? But no finding has shaken the world like this. The telescope uncovered massive, fully formed galaxies just 180 million years after the supposed Big Bang. In cosmic terms, that's a blink, an impossible sliver of time for galaxies to grow to the size of the Milky Way, organize into intricate spiral structures, and shine with the brightness the telescope recorded. According to our models, the early universe was a turbulent sea of gas, too chaotic for such complexity. Yet there they are, ancient giants, stable and radiant, as if they'd been there far longer than the universe itself. This discovery has cosmologists reeling. If these galaxies are as old as the data suggests, the Big Bang, long the cornerstone of modern cosmology, may no longer hold. Some researchers are now saying it openly. We may be staring at a universe with a history that stretches back long before our so-called beginning. In a desolate patch of space, far from any galaxy, the telescope detected something even more baffling: a gravitational lens effect where nothing visible exists. No stars, no galaxies, no black holes, just empty space. Yet light from distant galaxies bends, curves, and distorts as if something massive lurks there. Astronomers tentatively pointed to dark matter, the invisible mass that exerts gravitational pull. But this effect is too strong, too precise, too localized. It doesn't behave like a diffuse cloud of dark matter, but like an object, a structure with defined mass, symmetry, and edges. Could this be a cluster of dark matter condensed into a form we don't yet understand? Or is it something stranger, an echo of something ancient, still warping space in its silent presence? Some physicists are now whispering ideas once dismissed as fantasy. What if this isn't dark matter at all, but evidence of something built, something left behind? Then there's the intergalactic filament, a billion light-year-long stretch of galaxies and matter aligned with such precision it resembles a cosmic grid. Filaments are part of the universe's so-called cosmic web, but this one is different. Its density, its repeating voids, its near-perfect alignment make it look less like a natural formation and more like a framework laid across the cosmos. Galaxies follow parallel paths, dark matter clumps at exact intervals, and even the redshift readings pulse with a wave-like regularity. Mainstream cosmology insists this is just gravity at work over billions of years, but the symmetry is impossible to ignore. Some researchers remain cautious, warning that human minds are wired to see patterns where none exist. Others, though, are beginning to wonder if the universe had a builder, or if intelligence once shaped it, this would be where the fingerprints would show. Among the most provocative ideas to emerge is one that blurs the line between science and philosophy. What if dark matter isn't just invisible mass, but a carrier of information? In multiple observations, galaxy clusters formed in arrangements that seem to echo distant, older structures, as if the universe were repeating itself across time. What if dark matter, long thought to be inert, actually preserves a kind of cosmic memory? Not data as we know it, but gravitational imprints of past structures, shaping new galaxies based on ancient alignments. It's a radical idea, suggesting the universe doesn't just have a beginning, but a memory, a design that persists through eons. Every spiral, every void, every cluster might be part of a system far older than we ever imagined. But the most spine-chilling discovery is one few dare to discuss openly. During a deep-field scan in a void sector, the telescope recorded a series of pulses, light fluctuations too regular to be random, too faint to come from any known star. These signals didn't match the patterns of pulsars or quasars. They repeated at precise intervals, then vanished entirely. At first, scientists suspected an error, interference, a glitch, a trick of the data, but after rigorous checks across independent systems, the pattern held. The origin point showed no stellar mass, no nebula, no heat signature, just a steady, measured flash as if timed by something or someone. For now, official statements remain silent, but behind closed doors, researchers are grappling with a question that has haunted humanity for decades. What if this is a message? Not one meant to be answered, but one meant to be noticed. And if so, who or what was meant to see it? The James Webb Space Telescope was built to peer into the past, to strip away the layers of time and reveal the universe as it was billions of years ago. But in doing so, it may have uncovered something far deeper, that we are not just observers of the cosmos, but part of a system far older, far more precise, and far more deliberate than we ever dared to imagine. Galaxies that shouldn't exist, planets that defy gravity, signals with no source, structures that whisper of intelligence. These aren't random anomalies. These are data points, real and undeniable, and that challenge the very fabric of our reality. If the patterns are real, if the pulses are deliberate, if the universe remembers, then we must face the most unsettling possibility of all. We have never been alone. Not in time, not in space, not even in thought. What the telescope has revealed isn't just a map of the early universe. It may be a message, a system, a design, waiting for us to look deeper. And now that we have, the world will never see the stars the same way again. These discoveries beg a question. Are they signs of something greater, or are we merely seeing reflections of our own longing for meaning in the void? The answer lies not just in the data, but in what we choose to believe. The next image from the telescope might not just show us where we came from, it might show us where we're meant to go. The universe has always been humanity's greatest mystery, a canvas of questions painted with starlight. For millennia, we've sought to understand our place within it, building tools, writing theories, and chasing truths we could barely grasp. The James Webb Space Telescope was our boldest step yet, a machine designed to capture the light of the first stars, to reveal the origins of everything. But instead of answers, it has given us something far more profound, a challenge. A challenge to rethink what we know, to question what we believe, and to confront the possibility that the universe is not what we thought it was. The anomalies keep coming. In another observation, the telescope spotted a cluster of galaxies moving in unison, their trajectories aligned with a precision that defies the chaotic pull of gravity. These galaxies, spread across millions of light years, move as if guided, their paths converging toward a point in space where nothing visible exists. No black hole, no massive star, no detectable force, yet the gravitational pull is undeniable. Some have suggested this could be evidence of a cosmic attractor, a region of space exerting influence beyond our current understanding. Others wonder if we're seeing the shadow of something larger, a structure or force that operates on scales we can't yet comprehend. Then there's the matter of the cosmic microwave background, the faint echo of the Big Bang itself. The telescope's instruments, designed to study the earliest light, detected subtle irregularities in this radiation, tiny fluctuations that don't align with our models of the early universe. These fluctuations form patterns, almost like ripples, that repeat at intervals too regular to be chance. Some scientists speculate that these could be scars from a previous cosmic epoch, evidence of a universe that existed before our own. Others go further, suggesting that these ripples might be the imprint of a process we can't yet name, a process that shaped the universe with intention. The telescope's ability to see infrared light has also revealed something astonishing about distant stars. In several observations, stars far older than their host galaxies were found, their chemical compositions suggesting ages that predate the galaxies themselves. These stars, rich in heavy elements, shouldn't exist in such young systems. Their presence hints at a universe where star formation didn't follow the orderly progression we've assumed. Could these be wanderers, stars from a lost epoch, drifting through the cosmos until captured by newer galaxies? Or do they point to a recycling process where the universe reuses its oldest materials in ways we don't yet understand? Every new image from the telescope adds to the mystery. In one region, a void, a vast expanse of space with no galaxies or stars, showed unexpected activity. Faint infrared signals, too weak to be stars, flickered in patterns that suggested motion. Not random motion, but coordinated, as if something were moving through the void in formation. The signals were fleeting, gone before they could be studied in detail, but their presence lingers like a ghost in the data. Scientists are hesitant to speculate publicly, but the implications are staggering. Could this be evidence of something traversing the cosmos, something we can't see, but whose effects we can measure? The discoveries are piling up faster than explanations can keep pace. A distant quasar, one of the brightest objects in the universe, was found to emit light in a way that defies physics. Its energy output is too high, its spectrum too complex, suggesting a power source that doesn't fit our understanding of black holes or accretion disks. Some have proposed exotic explanations, perhaps a new type of stellar engine, or even a phenomenon we haven't yet named. Others are more cautious, insisting that our models of quasars need updating. But the data is clear. This quasar is doing something impossible, and it's not alone. Similar objects are appearing in other observations, each one a puzzle piece that doesn't fit. The telescope's findings are forcing us to confront uncomfortable questions. If the universe is as old as some of these discoveries suggest, what does that mean for our understanding of time? If structures exist with a precision that borders on the artificial, what does that say about the forces that shape them? If signals pulse with a regularity that feels deliberate, who or what could be responsible? These aren't just scientific questions, they're existential. They strike at the heart of who we are, where we come from, and what our place is in the grand scheme of things. The emotional weight of these discoveries is impossible to ignore. For generations, we've looked to the stars with a mix of wonder and humility, knowing we were small, but dreaming we were significant. Now, the universe is speaking back, and its message is both thrilling and terrifying. It's thrilling because it suggests a cosmos far richer, far more complex than we ever imagined. It's terrifying because it hints at truths we may not be ready to face. Are we part of a grand design, or are we merely witnesses to a system so vast it defies meaning? The telescope doesn't answer these questions. It only asks them louder and more urgently with every new image. The scientific community is buzzing with debate. Some insist that these anomalies will eventually fit into our existing models, that we're simply seeing the universe through a new lens. Others are more radical, arguing that we're on the cusp of a paradigm shift, a revolution in cosmology that will rewrite the textbooks. A few even venture into speculative territory, suggesting that the universe might be a construct, a simulation, or a creation shaped by intelligences we can't comprehend. These ideas, once confined to the fringes, are gaining traction as the evidence mounts. The public, too, is captivated. Social media is ablaze with discussions, theories, and wild speculation. People are sharing images from the telescope, zooming in on the anomalies, and debating what they mean. Some see divine intervention, others see extraterrestrial engineering, and many simply marvel at the beauty and mystery of it all. The telescope has become more than a scientific tool. It's a cultural phenomenon, a mirror reflecting our deepest hopes and fears about the cosmos. As the data continues to pour in, one thing is clear. The James Webb Space Telescope has changed everything. It has shown us a universe that is not just vast, but alive with possibilities we never dared to imagine. It has challenged our assumptions, ignited our curiosity, and forced us to confront the limits of our understanding. Whether these discoveries point to a natural phenomenon, an ancient intelligence, or something else entirely, they have one thing in common. They demand our attention. This is a moment of reckoning for humanity. We stand at a crossroads, staring into the abyss of the